technical seminar organized by Dynamic Foundry Group, Foundry Innovation and New Technology Summit held at New Delhi in 2017. He has also presented a paper in EastCon held at Jamshedpur in November 2017. So he has recently presented a paper in IIT Tirupati to student chapter organized by IIF Chennai chapter. Thank you. Senthil sir, over to you.
Good afternoon, fellow Foundrymen. It is indeed very happy and honored to be a speaker for today. Is my own chapter. First, I would like to thank Chennai chapter chairman and office bearers and council members for giving this great platform. I also would like to extend my gratitude to all members who have taken their precious time to join today's sessions. I'm sure this topic would be something unique or maybe a different from the Foundrymen, because we have been talking about all Foundry process all together this year, which is initiated by Chennai chapter. And every week we conduct this webinar and various topics we have been discussing. This is one parameter we're talking about weighing, which is very, very essential. When we go through this presentation, you'll be able to understand. The today topic we are named as Weighing and Beyond, a way forward to Smart Foundry. And this is a famous slogan we normally associate with our weighing instruments, like what gets measured, it gets managed, is said by Peter Drucker. This is applicable for any manufacturing industries. It is not only for weighing any parameters, including temperature, pressure, even energy, one of the biggest criteria for the foundry industries. And in terms of even other business management, like your financials, it has to be measured. Like weighing comes under this measurement. Okay, how do we associate with weighing? Weighing is directly linked with any company's bottom line, that is your profit. Like your energy, how it is costing you, like the weighing is also one of the biggest parameter, which is connected directly with your bottom line. Like we play a role in terms of incoming raw materials and alloys and additives, and how it has been consumption of happening, and in process payment and finished goods. See, we have been some time back, we have been talking about the price increase in the alloys, raw materials, and many parameters, which is we have been many foundrymen are gripping about it, and then we have been going back to the OEMs and ask for the price increase. But how much efforts we have taken internally to curtail our consumptions? If you ask this question, definitely there is no answer to it, because whatever we have influence we have in our process, if we can do improvements, that can create lot of impact. See, I have attended one of the recent one seminar where one of the leading foundrymen is talking about variables in the foundry industries. He's talking about more than 1 lakh variables. In this, the raw material payment plays a very, very, very vital role. Even if you can save 1% of your consumption of alloys, and the amount of money what you can save can be easy calculated by the foundryman, and very easy. Like you can take what is your cost of alloys or raw material you are spending in a month, and take about 1 to 2%, and if you can save on that cost, that would directly reflecting on your bottom line. How we can save it, that's what we are going to discuss about in this seminar, and with what are the systems can be put in place, we will discuss in detail. Okay, before getting into the topic, like I would like to introduce who we are. Few of you must be knowing about our background, but still people who are not aware of what is Senthilkumar and what is the company ACI Automation. See, basically ACI Automation is about 20 years old company, and having our own facility at Chennai. And we concentrate foundry very closely for the weighing and process automation solutions. And we have our own R&D center to develop the electronics and embedded programming, including PLC, app programming, and everything. And we also have our mechanical team and project team to execute the customized solutions. And we have been serving close to about 135 foundries across the nations. We have our local representation, all major foundry clusters. We have close, one of our key product is a crane weighing systems, which is used for mortar metal application, which has got close to about 350 installations across the nation. And you can see the few of the clients which we have presented in this slide. This is our background, and it's a purely Indian company. We don't have any multinational tie-ups, and all the process, whatever we are going to explain, has been understood from the great foundrymen. We have seen what are their pain points and where our experience can benefit them. Both have been merged, and we developed all these solutions throughout these years. And we are also in the process of improving a lot of solutions. I would not say the journey ends. We are continuing into the journey, and we are ready to take your challenges if you have anything in our experience line. Yeah, our presentation is going to be on this way. This is what is the choose the right weighing systems, and what is mean by validation of the weighing systems. And we will see how that digitalization on the POK process control would help in this process. If time permits, we will also touch upon the automation thing. I'm leaving it as an optional one. If time permits, I'm making myself as a target time of about 1 hour's time. I don't want to bore people more than an hour. If time permits, we will touch upon the automation solutions, or if time exceeds, we will take up this as a separate sessions at later time. Yeah, this is the typical foundry layout, and any MSME or a big foundries, there will be a weigh bridge to weigh your incoming and outgoing materials. And then when it comes to your stores, you'll be having a weighing scale. And when it comes to your furnace platform, you'll be using a crane scale to weigh a major raw metallics, and then platform scale for weighing the alloying elements. So let me check. Oh, but this is a platform scale. You use it for your alloying elements. Normally, crane weighing systems are used for metallics. And then if you come to the sand plant, you will have normally the OEM supply this weighing system. The sand plant, it comes along with that. There's a batch offer and additive offer, which is based on the load cells, so that the required proportionate of return sand and fresh sand can be weighed, and then additives like coal dust and bentonite can be weighed and mixed in the mixer. And of course, the final finished castings, which is to be weighed through the weighing scales. Of course, this is a Norway. Recently, there is a inoculant feeding systems also comes under the weighing. We'll also talk about this. Okay, I would be touching more on the furnace platform side. I think weigh bridges is the generic one. I think people have sometimes people have their own weigh bridges, or sometimes people use the external public weigh bridge to weigh the raw materials, and it is I don't believe it will attract major audience here. That's why I'm skipping the weigh bridges, and we will talk about the more on the weighing system utilized in the I have still close to about 400 foundries, 300 to 400 foundries, where I have seen the people have been struggling on these solutions. Like, either you have the very expensive imported weighing scale, or people are going with the local make weighing scale, which is gives a life only about 6 months or 1 year's time. That is the status we have seen it in the country. What we are trying to approach is that we are trying to do the integral type weighing systems, because this particular weighing systems has got a problem, because since it is very close to the molten metal, the life of the weighing scale is always minimal. And the second major issue is that when the SG treatments are happening, there is a lot of smokes comes out. You will not, people are not able to see the payment at all. They just do the judgment and then do the stop the tapping. And then the third point is that charging. You have to keep the your battery charged, always charged. One battery charges. If it is forgotten, then you will not able to use the weighing system. So this is the third major hurdle people are facing. And of course, as I told you, the life of the weighing system, by barring the imported one, and the local weighing systems are served very, very less lifetime. What we are done a change is that we are introduced the weighing system as the equalizer pulley, where the 50% of load, generally where the four falls mechanism, where the 50% load is shared by this pulley, where we put, instead of shaft we put a load cell. We introduce our electronics which is travels along with the CT, and the load cell is directly connected to this electronics which has got a Wi-Fi RF output, and this display is connected with our large figure display, and this display people can see from the ground level. The direct benefit of the system is this, since it is away from the temperature, so the life of the weighing system is ensured, and then it works on the crane power. There is no battery charging is required, and it eliminates all the problem which I explained in the just before I explained. This all the problems are explained. Okay, what is the uniqueness? Like, no, there are few people who also does this solution, but what is the advantage of the system is, like, it has got remote calibration. Like that means, like, whenever you want to calibrate the system, basically you have to go top and fiddle these keys. There are four keys where you have to fiddle the keys. That is the case for few of the manufacturers. For our case, we provide a wireless remote where you can calibrate the system by standing in the ground level. You don't need to go top every time, even it is the case of say 3 months once or 6 months once. It is will be appreciated by the maintenance team. Basically, how we are attaining is, basically we are synchronizing this both main electronics and displays. What is the beauty? Like, you can ask the question, like, what is the beauty? And if you check with any manufacturers, the any weighing systems in general, it will communicate to the external device, whether it can be a display or can be a PC software. It will communicate only at the weighing mode, not in the setting mode. If you go to the setting mode, and this display will be blank, because this gentleman will not send any data to the external device, so the people will not aware what's happening. Like our case, what we did is, since it is a mandatory requirement, we made it such a way that even at the setting mode, this data sends to the external display, so that people can see from the bottom and do the calibration. That is one of the biggest change we have brought in. And second thing is, like, we also provide a power panel so that the electronics life is getting increased, because since we are using the crane power, uh, there will be a lot of noise would be generated whenever the crane movement is happening. And to avoid the this effect, we are introduced this power transformer. There is a isolation transformer is introduced, so the regulated supply goes to the main electronics. The third one is the rope weight compensation. The rope weight compensation means, like, you have the you have to keep the object at the same location. Like, suppose it's a crane, you have the object here, you got a different weight. Suppose object is kept in the middle, you get a different weight because of the rope length. Please remember that we are measuring at this level, not at this level. We are measuring at the top. This also plays a bigger challenge to us. To overcome this, we have introduced the encoder so that we understand the rope length, so that accordingly the weight is compensated. Whether irrespective of location, whether it is in the bottom or a middle or the top, you get a same weight reading, so you will not get any variations. This is also one of the major change we brought in our weighing systems. Then apart from that, we don't consider this as a weighing systems. This also used as a uh, data recording system. Like, you will be able to measure how much molten metal you have produced in the shift or in the day. Like, press of button at the remote, the data gets stored at the computer, which is within the vicinity of 100 meters. Through again RF signal, we put RF receiver at the computer end, and also our receiving software, which will get recorded the data along with the date and time, so that you'll be able to know how much molten metal is produced. And we also provide additional displays. This is a standard display, and this is our multifunction displays, which basically used to give a poke function. For example, if you want to tap around 1000 kg with a tolerance of plus or minus say 10 kg, and you can fix the target weight in this display. If it is out of the tolerance, apart from the weight indication, the display also there is a tower lamp. This the red will get glow and give a alarm. And if it is less than the tolerance, the yellow will go. Within the tolerance range, the green will go. This gives the additional okay indication to the operator, so that it is make their life much easier, and it is also much appreciated by the lot of buyers. Even this system is used for molten metal, and we provide this remote. But whereas if you use the same weighing system utilized for your raw material application, just by registering the weight, it may not serve the purpose, because you should know what is the material is gets weight, whether you are weighing a pig iron or CRC or a boring. If you can identify along with the material, then that gives a more value to you. That is why we have introduced the wireless display, where it has got a facility to select the material name. It has got a two-line display. The first line will show the material name. The second line will show the weight. By using the up-down arrow key, the operator can select the material names. Suppose if he's picking up pig iron, he can select pig iron and press register button, so that then the computer it gets stored pig iron is taken so much. So end of the day, you will come to know material wise how much material has been consumed. See, I am giving a point of caution here. I am giving the data only shift wise, not as a heat wise. You will not able to know how much metallics are used for the particular heat number. For that, this solution will not help, but it is to give you for overall consumption report, and this system can help you. And for heat wise report, we have another solution which we can see in the next couple of slides. There it can give a data, heat wise consumption data can be produced, and this data also can be uploaded to your ERP or any IoT. If you have centralized IoT systems, we can give a data link to that system, so that the data can be directly captured to your main systems. That is the one more advantage of these systems. This particular system, just give an idea, as I mentioned in the beginning, we started with about 10 systems about 7 8 years back. And after studying the market and giving all the values to this product, we have reached as of now close to about 350 numbers, and it's well appreciated product. And we have been competing with major multinationals on this product, and we get a lot of repeat orders for this particular solutions. And many places people are still go with the lower end hanging scale, which they get a lot of issues. This would be the alternate solution, where they can think of this particular solution to get the molten metal or raw material payment data. Okay, I just skip this. Okay, again, the one more factor which I would like to talk about, the accuracy factors. Like, we see people sometimes talk about the accuracy, whether what kind of accuracy your system is having and things like that. See, what is the accuracy? Like, it is accuracy basically depends on the uh, where you are using application you are using. See, you don't you have seen the picture here, right? Like, you have seen the right hand side, there is a jewelry balance where we talk about accuracy in the range of milligrams. Okay, because there you are paying money, they are very expensive, that we are paying the milligram level, people measure it. When you go to the grocery shop, it is normally in the range of grams, say 10 grams or 50 grams, 100 grams, like that. We talk about the person where we don't need that much accuracy. It normally in the 500 grams to 1 kg level. It you are required accuracy defined applications, like, no, you have to decide. For our crane weighing applications, it is very well accepted that plus or minus 5 kg for a 5 ton, or plus or minus 10 kg for a 10 ton accuracy is very well accepted in the market, and we are able to provide for the throughout the range. And just to want to give the data, I'm sharing this information. Okay, next, coming to other weighing systems, like platform scales, which is widely used industries for to weigh the alloying elements as well as your stores. What is the selection criteria? Like, you got a n number of players for these applications. It is one of the, it's almost become a commodity. My recommendation would be you see that what kind of load cell they are using, because don't go with the lower end like the Chinese load cells where the reliabilities are always question mark. And see the background of the people, like what kind of electronics, because this what happens, the people nowadays get electronics from somebody and then assemble it and supplying it. When it comes to support, they are not able to do it. You see the find out the reliable partner who are in this business for a quite long, and ensure that the it has got a communication port, because normally what happens, we want to go for next level of data integration, and you need to have that communication port for the weighing system, which normally majority of the major multinational players that provide this data, but few local manufacturers do not provide that unless you ask for it. Main thing is that they're after sales support, you have to see. The third one is the vibrator transfer car weighing systems. Like many people nowadays trying to introduce the weighing system as a charging car itself. These are it is a one of the biggest challenges, that it has to be designed in such a way that load is 100% acted on the load cells. You need to go for very special load cell, because normal load cell will not serve here, because it has got a lot of vibration. Check for the special load cell, which there are special load cell available which takes care of the vibration, so that the life of the weighing systems are ensured. We have supplied special load cell for this application, which have been serving the market for last say about 3 to 4 years time without any issues. It is expensive, but it is a one time investment, and it can solve your all your problems. Okay, next we come to the validation. I'm not sure how many people are aware of this validation. Can I have any feedback on this validation part? Basically, people misconception about the calibration and validations. Calibration is you are correcting the system by doing a reference weight. Validation is you are verifying it whether the instrument is delivering the required residue accuracy or not. Suppose you are saying 100 kg plus or minus 10 grams, whether the weighing system is linear till from the zero range to the 100%. That validation, that is called validation. Generally, we recommend to do validate the weighing scales once in a say month or 3 months once, and calibration needs to be done 6 months once or once in a year. See, this plays a vital role, because normally this is one of the neglected factor in industries. Generally, what happens, we use a weighing scale, based on that we weigh the alloys and do addition in the furnaces. Then we check it everything. Then we see that there is a variations. Then for a cross verification, we go back whether weighing scale is okay or not. It is more it is visible on the weighbridge business. See, weighbridge business, what happens, like people have weighbridges, they do a weighment and they supply material to the suppliers. When the suppliers come and tell the complaint that okay, the weighment is wrong, my weighing systems are showing different, your slip is showing different, then we do all back verification what went wrong and things like that. Then where weighbridge is verified with the test wise whether it is showing right weight, and then only the correction factors are taken in. But it is by the time already the damage is already done. What we recommend is, if you can have your SOP, standard operating procedure, where you can give your people schedule that okay, once in a 3 months you have to verify, or once in a 1 month you have to verify the weighing system with a set of procedures. Say you have to weigh up to 100% or weigh up to 50% with the reference weight, verify the weighing systems and ensure that it is performing its performance. It is not only applicable for the weighing instruments, it is applicable for any instrument like temperature, pressure, anything, energy meter, whatever it is. No, you have to validate it so that you will not get into the surprise. This is one of the biggest point which is neglected by the people. We take care of this in our system by in our software, where our software has got a facilities where you can define the validation, and then it give a alert to the people so that they do the validation. Then only they will be able to do the weighing systems. And the procedure of validations also can be recorded in our systems. That is the facility we are providing in our overall solutions. Can we come to the next part? Okay, okay, which I talked about, okay and digitalization part of this. See, what is okay? See, as per the Japanese, they say that people make mistakes when they do repeated jobs. They tend to make a mistakes. The good okay device makes it impossible to make a mistake. That is what okay definition is all about. And we are trying to bring this concept to the Indian foundry industries, like where predominantly into the HG treatment process and the furnace melting platform process when the payments are happening. Okay. Yeah, let's get into this ladle ferroalloy addition. This is, we call it as for HG treatment. See, everyone is aware of this HG treatment process. It's basically for the sandwich process where molten metal is taken out from the furnaces by the time these treatments happening at the ladle, and then they go for the pouring directly. Please note it, people do not take any samples when the treatments are over. The samples are taken only after the while starting the pouring or end of the pouring, and the coin result comes out only after pouring is completed. And unlike your base metal where you check the sample, chemistry is okay, then only the pouring is then only tapping will happen. Whereas in the SG treatment, we don't have time because the molten metal has to be consumed within 720 seconds. So that is the parameter. That is why people follow this process. Imagine that if the sample comes out and then the result is wrong, the whatever molten metal you have poured, the entire casting is going as a reject. That means you have produced your own rejects. Then everything comes back to a system as a rejects and then use it for the same molten metal. Use it as a raw material. Even if it has happened for one or two batches, you can calculate the kind of cost involved and what is the productivity loss you involved. But when we discuss about this particular point, but sometimes we get a question, people say that no, okay, anyway, I'm not losing anything, I'm going to use this as a raw material, I'm not losing anything. But the answer to this is, I have seen one of the our past IIF presidents, one of the articles they mentioned to the foundrymen that dear foundrymen, we are not in the business of making our own raw material. Okay, the statement says very clearly, we are not in the business of making our own raw material. That means like you must have got it by raw material very less price. If you can create your own raw material, there is no use, and that justification is get nullified by this statement. So how it can be avoided? Like, okay, now we'll come to the solution. How it can be avoided in a typical Indian MSME foundries without investing much. Okay, this is the point which you talk about. The idea is to see how we can do it right at the first time at every time. Okay. See now, I will also run a video to give a clear picture on this. Okay, how do we do this? Is that we provide a terminal called BST, which is called Batch Supervision Terminal, and you can simulate as an electronic supervisor, which is connected with the weighing scale. Typical any weighing scale, as I told you already, that it has should have the communication port. Okay, this BST is connected with the computer through Ethernet or through RF's wireless signal, and we run a software in a computer where no, you can define your product details, like no, what is your ferrosilicon quantities required, what is your covering material quantities required, what is the molten metal quantities required. These can be defined in a computer as a product. When the manufacturing starting, the supervisor has to go and start the in the computer, okay, I want to run this particular product and so many batches. The job at the computer is over. I will also show the screen at later stage. And when this starting is done at the computer, this BST will show the what material to be weighed, what quantity to be weighed. You will see it in this display. Particularly the first line will show what is the material, what is the alloys to be weighed, and what is the how much material to be weighed. And when they do a weighment, basically it will also give a alarm. So it will say that suppose you want to weigh the 10 kg of ferrosilicon material, and it will say less than the target weight, it shows the yellow light, and if it is more than the tolerance weight, it shows the red light. Okay, I think just give a better picture. I will run this video. Okay, but I think the link is not there. I'll just go to my YouTube channel.
I'm not Harry Potter, but let me show you a magic trick. This is my Excel data. See these boring numbers? If I go and present this in my meetings, my audience will simply fall asleep. Now, what if I just turn this boring numerical Excel data into this interesting, visually appealing presentation.
Are you able to see my video?
Yes, sir. It's we can see it.
Are you able to see, right? Yeah. So this is a typical screen where it has got a 3-layer of password protection. And you create a master. What is the ferrosilicon and covering material? Sorry. And it's got a user master. Is also, you can also define the shift. And this is your scheduler. When you want to do a production, you have to say what material you are going to product we are going to do the process. So once the scheduling is done, that this is a terminal. It's a very rugged terminal which is kept near the weighing scale, and it gives in a baby steps to the operator. You say first says that are the container. They have to keep the container and press a button. It gives a what is the material to be weighed, what is the set weight, what is the actual weight. They don't have to see the weighing scale. They can see this terminal itself. I can see. See now it is less than the weight. They are trying to press a button. Okay, additionally, he has to do this, press a button. It will not accept if it is less than the range. And even if it is goes out of the range also, it will not accept. Then he has to take out the material and bring it to the required range. Then he has to press a button. This is ensure that he is weighing the right quantity, what is specified by the team leader. The next option again is to start the container. It shows the steel covering material. So now both the materials are weighed. It says batch over. Now we bring the ladle to this place and put the alloys inside. So the batch is discharged. Then the furnace operator will come to know how much molten metal to be tapped. Now weight will come from weighing system. Once the molten metal target is reached, he is registered the terminal by the remote. When the molten metal is tapped, the timer is also start automatically. So generally, the timer will be somebody has to go and press start button. And our case, this timer will get automatically started. See, optionally, what happens? You can also have the storage container, because weighing scale will not understand whether I'm weighing a ferrosilicon grade 1 or grade 2. If you want a material control, you can have a bin like this. So you must be using a two different ferrosilicon. Maybe one is from SNAM, one is from Elcom. Maybe certain products use SNAM alloys, some certain products use Elcom alloys. It both are look like same, and maybe the new operator will not come to know which alloy to be added. That case, you can have the bin like this. When the system says the particular alloy, only that bin will open. When the registration is done, automatically it get closed. It also has got a voice model, so that people who are not able to read out the English, it will give them a local language the instructions. Like no, it's a baby step. Baby steps. It will give the instruction like do a payment, weigh karo, weigh tik naya, like that. It will also tell in Hindi, so that people will not make any mistakes. Is it clear? Can we proceed?
Proceed, sir.
Yes, sir. We can proceed.
Yeah, this is a system, as I told you, it's a okay system where it ensures that the each and every treatments are done without any mistakes, and operated dependency is totally eliminated. The idea is not removing the manpower; it will de-skill the manpower. Your okay systems will help you to de-skill the people so that anybody can put on the job. See, this is the systems running in many couple of places. One of the clients, like I would say, the Breaks India, it is running for last say about 7-8 years. See, this system was running in this patient for last say about 4 years back till it was running, and suddenly we got a complaint saying that no, again we have some one treatment got failed. We do not know what is happening. Then we went and then studied along with the customer to identify what is the root cause. See what happens. Like you have seen the video, right? Generally, they have to press a discharge button when the alloys are play put inside the ladle. That is the procedure they supposed to follow. What happened? One operator in the night shift. What he did is that he made a practice pressing a button, then put a alloys in the ladder. It become a reverse. Then one case he has forgot to put alloys, and then ladle as an empty ladle it has gone for a tapping, and then molten metals get tapped, and then it has gone for a pouring. The entire rejections are happened. Now, to how to identify what kind of we brought in, we had a brainstorming session. Then what we have done is we introduce a separate platform scales. One second pointer. Yeah, we introduce a separate platform scales with the capacity of say about 2 ton capacities, where the once the alloy is weighed, and we give an announcement to operator to place the ladle, empty ladle here. An empty ladle is placed, so automatically the ladle get zeroed, and then the crane hub hoist get the connection get cut. That means you after placement of the ladle, they will not able to lift the ladle. Now we give the announcement to put the alloys, whatever weighed in this particular weighing scale. It is we put a announcement to weigh it, put it on the ladle, and when the ladder alloys are put in, we sense the weight. Okay, suppose here say 10 plus 10, 20 kg means 20 kg both the alloys and covering materials are get into the ladle. Then we release these hub hoists so that they'll able to remove the ladle from the platform scales. Here we are ensuring that 100% whatever weighment they are done it at the weighing station is put it inside the ladle in this particular station, so that the mistake whatever happened without alloys has been 100% eliminated. So that kind of all your crane weighing systems up hoist and including the alloy weighment, everything gone been synchronized so that the treatment goes without any issues. This is additional POK also can be implemented. This is also done it in a couple of other projects where we have subsequently implemented. Yeah, this is we talked about the ladle addition, and we will come to our furnace base metal. See, like how you are doing a ladle addition, same way it is for your you for a base metal for cast iron. You do alloy payments, and then also do a payment for metallics like your pig iron, CRC, borings, all those things are payments are done. And generally nowadays, what happened? People give the recipe paper or maybe a display board where the operator has to see that, and accordingly it has to be weighed and put it onto the charger. Then it get dispensed to the furnaces. This is the general practices. And then whenever they do a payment, and it is they put it on the logbook, and then the logbook data is converted into maybe ERP or Excel sheet. See, here only we merged our both digitalization as well as the OK systems together here. See, now we look at the system. There are we see about 3 layer of mistakes. Like what happens when they do the weighment of alloys, okay, and there could be a weighing mistake. Okay, whether he does it as per the requirement or not, nobody knows. And second issue is that when these read out this data and put it on the logbook, when he's write down, there could be a mistake. And then third mistake is when the log data is again converted into your ERP Excel sheet, the data entry mistake. There are 3 layer of mistakes are happening, and with this data only, all our decision making patterns are happening. Like, okay, we in this process, what we are trying to do is we are trying to eliminate these mistakes and trying to take data from the instrument directly, so that the no manual intervention is there. And second is that we introduce the POK principle so that the right material and right quantities are weighed at the first time. And the third portion is that we are trying to interface the spectro and try to do the corrections part of it also automatically. I will explain in detail how it has been done. See, you were for the alloys, you already have the scenes. The same terminal is introduced for the alloy weighing scale, and we provide a bins like this for the material mismatch. Ke liye we provide a bins so that bin control is also possible. And for the big metallics, we provide a scorecode like this, scorecard like this for each and every furnaces. If you have a three crucible, three displays, or if it is four crucible and four displays, and this is what our software looks like. I told you last time that our software for both HG treatment as the base metals are common. And this is our main screen looks like. And the upper part portion is done by the administrator, which is a one-time exercise. And then this part is done by the supervisor, rescheduling and everything. And operator can just see what is happening. This is the main screen, and these are the communication which is happening with the instrument. It's all give an indication whether communication is in live or not. All this information comes in the dashboard. This is the product master. Suppose of a particular grade, if I'm doing a G4 500 by 20 or whatever grade, and what is the raw material metallics, what is the set weight, what is the tolerance you can allow. You can create a product master. You can create n number of master in this schedule. Suppose we have this data in ERP, we can fetch data from the ERP directly. And the same way, we also maintain the chemistry masters, like what is the carbon minimum, maximum, and silicon minimum, maximum. All the parameters can be entered one time, or it can be again, as I told you, we can take it data from the ERP automatically. And the user masters, where we have administrator, supervisor, and operator level. And generally, administrators we provide only one person, and you can have multiple supervisors and operator. And shift master, where you can define the shift. And then, as I told you, the validation of weighing systems. If you recollect that we discussed about the validation for the every weighing instrument, you can give the validation time period, and so that it gives a prior intimation to the operators. Yeah, this is the schedule master. When you want to do a production, you select the particular furnace, and what is the grade to be manufactured, how many batches to be manufactured. You can define it for multiple grades for a multiple furnace. This is the schedule master. Once it is done, the operation start at the main display level. I just run a video so that you get a clear idea how it is happening. Sorry. Are you able to see my video?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
The weighing system is introduced at the raw material crane.
Sir, the video is like a slideshow. Just checking.
What?
Is the video like a slideshow, or is it like number of pictures compilation?
No, it's a video only, direct video only.
How long would that take, sir?
It is all depends on the time what we have.
If it's like 5-10 minutes, I think we can extend it.
Okay, what I'll do is I will not go in detail. Just give a conceptualize so that people have the idea, like whoever would like to think of it. Maybe the detail one can be discussed later. Okay. So far,
Sure,
what we
sir.
discussed is the with the manual intervention, which is typically useful for the Indian foundry industries, and it is widely used. And this is total automatic layout, and which is implemented at one of the foundry at Jaipur, Universal Auto Foundry, our current IIF President site, where the metallics are weighed automatically and dispensed automatically into the furnaces. Like there you have seen somebody has to operate the crane, take the material and put it on the charger, and then charger get dispensed here. Like what we have done is the typically layout is apart from your bay, the customer has constructed the storage silos like this, the elevated storage silos, which has got a vibrator. And apart from a regular charging car, there is a one more vibrator which is moves on this direction. Okay, this has got a load cell. We introduce a load cell. This gentleman will act as a like a robo. Your all software, everything's are common, same software. When you selected the particular gate, this charger will travel to the particular location, collect the material. Suppose it needs to collect the borings, it goes to the boring station, collect say 1000 kgs, and comes to the pig iron station, collect the 500 kg, whatever materials are as per the plan. It goes automatically with the help of the position sensors, and motor is driven by our PLC control system, and then it comes to the particular furnace charger and dispense the material. It's a three layer. This is a first layer, and it's a little elevated, and this is on other elevated locations, so that this material get dispensed automatically to the furnace. The only challenge here is the layout. It is typically for the new foundry, it can be accommodated, and the sizing of the raw material also has to be managed. Your various size of scrap or those things cannot be managed here, because it will not get transported through the vibrators. That is the biggest challenge. But he is operating typically with 2 to 3 manpower, where it's supposed to be operated with the 10 manpowers. And it is I think it has been done in some of the Japanese multinational companies in Japan. The customer has seen this concept, and then it has been discussed here. All the control systems, everything has been supplied by the last 3.5 years in the market. It is working well, absolutely without any issues. Here the same thing. Alloying also can be done like this. Alloying is alloying also can be done in the storage silos. Like it can have about 8 storage silos, which has got a vibrator and it has got a weigh bin. Based on the recipe, again, it will dispense the required quantity of alloys here, and it can be collected manually, put it onto the furnace directly into the furnace. That is, as of now, we are not any automated. Both alloying elements and this metal again goes to the computer, and then we again read a spectro. Again, correction boxes is same as our Poke system. Same thing can be possible. Again, alloying elements, you also have the sizing issue. Sizing has to be taken care. When the sizing is taken care, it 100% possible to do a implementation, and it should be a granular format. If you have a wire mesh, sometimes people use wire mesh copper kind of thing, which cannot be transported. It should be a granular form. Then only the system can be implemented. In fact, right now we are also in a discussion with one of the customer, where it is automatically with some mechanical arrangement, this material gets conveyed to the conveyor and dispensed on the charger, so that the even alloys are getting dispensed directly on the furnaces. That level automation is also possible. This is of course the layout change and the sizing is the two major criteria. Okay, and comes to the HG treatment, like whatever we discussed is okay, where manual interventions are involved, whereas this system is totally is a dispenser. Okay, you don't need any manual intervention. It has got a storage silo like this, and it has got a vibrator. It has got a vibrator. It has got a weigh bin. Okay, based on your recipe, this vibrator runs in a 2-speed. We call it as coarse and fine. Suppose we talk about 10 kg, maybe up to 9.5 kg, it runs in a very high speed, and then up to for 500 grams, it runs in very slow speed, and it gets weighed and then kept it here. And depends on the number of materials, ferrosilicon, magnesium, covering material. Suppose you have another grade of alloys or inoculants, or are put here and weighed and kept in the weighing bin. There's a conveyor, and where the called discharge chute. Normally, it is in an elevated position. The ladle has to brought here, so that when the ladle is brought here, press the discharge button, then the chute goes inside. This particular chute goes inside the particular packet, because the alloys has to dispense into the particular packet for the better treatment. It goes inside, then conveyor starts running, then one by one material get dispenses, so that material goes into the ladle automatically. Then the ladle is taken for the molten metal payment. This is totally automatic. You need a person only to fill this storage silos once in a shift or once in a day, depends on the capacity we choose. And this is we have close about 9 to 10 installation in the market. All are working in a good conditions. This is for edge treatment, because edge treatment you cannot, since you cannot mix the material, you have a separate weighing bins. Whereas for the furnace alloys, since the alloys can be mixed, you can have a common weight. Okay, just short of time, I'm not running any videos. This is a typical alloy feeder where ladle can come, the chute can go inside. This is the comparison, like what is automation and semi-automatic. This is typically you need a layout change, whereas for this can go for existing layout. Sizing and uniformity is very important factor in automation, whereas the sizing is not a criteria in semi-automatic or digitalization. Because investment is little high, here the investment is low. Here your reduction of manpower is 100% possible. Automation for 100% is possible, whereas semi-automatic manpower de-skilling is for you are not reducing a manpower, you are de-skilling the person. Process control is at 100%, here close to about 98%. Automatic data capturing, and more suitable for new project. It is more suitable for existing plants. Or sometimes people go for combination of both. Sometimes people for metallics, they go for base metal. For the base metal, they go for semi-automatic. For alloying elements, they go for auto alloy feeder. The combination is also possible. Of course, this is covers. Of course, as I told you, like we also have some solution for inoculation feeding system for ladle additions, and then for a stream inoculation. These are the solution. Again, it is based on the weight. We have the solutions, and casting counting. We are also for machining. If you are sending a casting outside, we have a special machine called online casting counting machine, which also can help the customers. Thank you. It comes to end of our session. If any questions are there, I can answer it now. If anything is not there, then I can give it to the organizers. Thank you. Thank you very much.
Thank you, sir. We will keep the session open for 5 minutes. For any questions, please feel free to reach out or text in the chat box, and I'll be happy to read it out. So, sir, I just had a personal question.
Yeah.
One was when you explained something about calibration validation.
Yeah.
When you were explaining, I know I saw that you were showing only the results of what a calibration is, what a validation is. Could you just elaborate that again? Like, why do you say calibration is? Validation is more important than calibration. How do you calculate it?
See, normally we misinterpret both terms. Basically, what happens? Calibration is you are correcting the machine to the desired accuracy. For example, if the weighing scale is not showing the right weight, you are with the reference weight, you are doing a correction factors. You are doing correcting the system and making all right.
Correct.
Okay, that is the calibration. But validation is not that. Validation, you are checking the system whether it is showing as per the desired accuracy or not. You don't do any calibration, which is more important. Like, no, you don't. Frequent calibration is also not acceptable. Not acceptable. That means there is a some issue in the system, overall system. You are trying to cover up for the particular period of time. That's about it is. Validation is you have to do a periodically whether instrument is showing the right accuracy, right resolution for the desired one. You have to check with your. It can be for anything. Whether it can be weighing or a temperature, any instrument for that matter. Every instrument has got its own procedure to do validate the systems. You are not touching calibration. Validation can be done by the your user itself. The calibration may require a technician or your maintenance person. The validation is you don't need any special skill. Your operating team can do it.
Okay.
See, pharma, that's what I told you, the pharma industry. Pharma industry goes with very, very stringent SOPs. Every day when they use a very high precision balances to check the samples, chemical sample, the samples, okay, then the laboratories. and every day before they start using the balances, the balance has to be validated. They have a test. Suppose if they are using 220 grams with 1 milligram balance, and they have a defined process, like no, say put say 10 gram, put 100 grams and 200 grams. Those test weight has to be put, and they have to note down the result of the weighing system, that it has to pass within that accuracy level. They have to generate the report, then they should start operating for the samples, and that record is also validated. There is something called FDA, for Food Drug Association. They validate even that data, whether the machine is being validated everyday basis, because it's very important criteria for them. That is why that level is important. That's why for other industries it makes it mandatory, so that we don't have to doubt about the instrument. Otherwise, we have back of the mind always we have doubt about the instrument, whether the instrument has shown the right weight or right temperature and things like that. That is the difference.
Okay. All right. I had actually already started the closing process.
Okay.
When you were away.
Sorry.
No worries. Sir. So I again thank you for your time, because as I said earlier, Senthil sir is a very, very passionate person about automation. Anything regarding automation and its improvements and latest technologies, Senthil sir will always be there to explain and guide us. So in that aspect, I thank him for his time, and I thank everyone for attending the webinar. And please follow our YouTube pages, our YouTube channel for more information, and keep update with our upcoming programs. And I thank you all for the.
Thank you, Siddharth. Thank you, Prasad. Thank you very much. Thanks for everyone. Thank you.